Okay, so we've learned how to write chemical equations. We've learned about balancing chemical equations, and now we're going to learn about the types of chemical equations. So the first type we're going to learn about is synthesis reaction, and this is just when you're going to make one thing. So it occurs between two or more simple things, and then they combine to form a more complex thing. So here's the general form of the reaction. So you're going to have something plus something. So here we have an A plus a B, and that combines to make one thing. So here it's an AB. Okay. So here's an example. You have iron in the solid form plus oxygen in the gas form, and they combine to make iron oxide. So that's just rusting. So what's always true about a synthesis reaction? Well, at the very end, you always have one single product. So the way you can pick these out is there is one thing on the right-hand side. Here is just a visual representation. So here you have start with two things. They combine to form one thing. Okay, so now we have decomposition. And this is going to be the exact opposite. It's going to be exactly how it sounds. Decomposition sounds like decomposing, right? So it occurs when a substance breaks down into two or more simpler substances. It's going to be the opposite of a synthesis reaction. Here's the general format. So you're going to have something combined. Here's an AB combined, and that's going to make an A and a B separate. Here's an example of an equation. So you have water, and it would break down into the two parts that water is made out of, right? Hydrogen gas and oxygen gas. So what's always true of a decomposition reaction? Well, the reactant is always one single compound. Or, in other words, you'll have one single thing on the left side. Here's a visual representation. So you start with one thing, and then it's going to break down into more than one thing. Okay, so now we have a single replacement reaction. This is probably one of the harder ones to determine. You're going to have atoms of one element that's going to replace the atoms of another element in a compound. So here's the general format. So you're going to have one single thing by itself. So here we have an A plus a compound. So we have two things that are together. Here we're representing it by B and C. And then on this side, on the right side, they're switching places. Notice the A switched places with the B. Here's an example in a chemical format. So you have copper, and you have silver nitrate. And this is actually silver nitrate. And so the silver and the copper are going to switch places. On the right-hand side, we're going to have copper, nitrite, and silver. What's always true of a single replacement reaction? Well, when you look at it on the left and the right side, you are going to have a single element and a single compound. And remember, you know the difference between an element and a compound because elements have one capital letter. See, this is one capital C. And then you have more than one capital letter in a compound. So 1 capital, 2 capital, 3 capital. So element, compound, compound, element. So this is single replacement. Here's a visual representation, so you can see the different colors. So you have a yellow and then kind of a purple and a blue together. On the right-hand side, the blue's by itself and the yellow and the purple are together. Double displacement is where you have atoms of two different compounds and they're going to trade places with each other. So here's kind of the format. You have an A and a B together added to a C and a D together. And then just everything's going to mix up on the other side. Here's an example of chemicals. So you have silver nitrate and potassium chloride, and that's going to make silver chloride and potassium nitrate. See, everything switches up. What's always true of a double replacement reaction? On both sides, you're going to have compounds everywhere. Compound, 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 compound. Here's just a visual representation. So we have yellow and kind of this orangey color plus purple and blue. And then on this side, you have yellow and blue together and orange and purple. So you see that they visually switch places. Okay, so 2 more kinds. We have combustion, and that's any hydrocarbon. A hydrocarbon is kind of what it sounds like. Hydrocarbon. So hydrogen and carbon. Sometimes they have oxygen mixed in there too. And that's going to react with oxygen to produce carbon dioxide and water. A large amount of energy is going to be released as light and heat. Here's the general format. You're going to have a carbon-containing compound, or that hydrocarbon, plus an oxygen, and you're going to make CO2 and water on the right. Here's an example of a specific reaction. Okay, we have methane gas plus oxygen, and you make that CO2 and water. What's always true of combustion reactions, you're going to have CO2 and water on one side of the reaction. So that's an easy way to pick it out. So if you see CO2 and water, it's combustion. Our last kind is a neutralization reaction. A neutralization is of an acid and a base producing water and a salt. The general format is you have an acid, and we haven't learned this yet, but an acid starts with an H. So you have H something, and a base is something with an OH on the end. And then you're going to make a salt and water. And remember, salt it isn't NaCl. It is a metal with a halogen on the end. So here's an example. We have HCl, which is an acid, hydrochloric acid. And then we have NaOH, which is a base, sodium hydroxide. And then that's going to make a salt, which NaCl is a salt, that's table salt, sodium chloride. And then water. So what is always true about the neutralization reactions? How do you tell? Well, if they make water, but there's no CO2 with it, then that's going to be a neutralization. So all chemical reactions are going to involve energy, and they're either going to release it or absorb it. And it's going to be in the form of heat, light, sound, or electricity. And chemical bonds are that source of energy. And breaking bonds is going to require energy. And forming bonds is going to release energy. So we need to talk about exothermic and endothermic reactions. An exothermic reaction is a reaction that releases heat and gives off. It releases energy and it gives off heat. So it's going to be warm. An exothermic reaction may also release energy in the form of light or sound. An endothermic reaction is a reaction that absorbs energy in the lowering of a temperature. So this is going to get cold. And it also could be reactions that need light to proceed, such as photosynthesis.